Hi everyone, my name's Sean with Axiom Tutoring and I'm going to be your GCSE Maths tutor. This is part one of a two-part lesson on factors and multiples. At higher level, factors and multiples aren't really a topic, they're more of a foundational concept that will allow you to access higher topics, and so even if this seems easy, I would recommend staying until the end of the video. Now, what is a multiple? The multiples of a number are the numbers you get when you take that number, let's say 5, and multiply it by whole numbers. So you could multiply 5 by 1, you get 5, 5 by 2, you get 10, 5 by 3, get 15, and so on. And we call this the times table of 5, or the multiples of 5. So let's see what happens when we list out some of these multiples. The multiples of 5 are 5, 10, 15, 20, and so on. The multiples of 10 are 10, 20, 30, and so on. And you'll notice that some numbers have multiples in common. 5 and 10 have 10 in common, and 20 in common. The first numbers that appear in both times tables, or the first number that appears in both, is the lowest common multiple, and we'll refer to it from here on as the LCM. Now, even if you've never explicitly worked out the LCM, you've been doing it for a long time when you add fractions with different denominators. So we would try to find a number that is a multiple of both 4 and 6, and we know that is 12. It's the first number that appears in both times tables, and you would turn this into 3 over 12 plus 2 over 12 and get 5 over 12. That's just one use of working out the LCM. Let's look at another one. Imagine that there are two trains on a platform, train A and train B. This is supposed to be a train that I'm drawing. I'm a math teacher, not an artist, but it's there to help you visualize the situation. The trains meet on the platform for the first time at 9 a.m. After that, one of them comes every 2 minutes, and the other comes every 3 minutes. So at 9:01, neither of the trains are on the platform. At 9:02, 2 minutes after the first appearance, train A is on the platform, but train B isn't. At 9:03, train B is on the platform because it comes every 3 minutes, but train A is not. We can continue this to 9:04. Train A will be there, but train B will not. Forwarding to 9:06, train A will be there and train B will also be there. And so the first time that they meet again after leaving is at 9:06, and that's because the LCM of 2 and 3 is 6. And so every 6 minutes, the two trains will both be on the platform. So if you want to jump straight from one train to the other, not spend any time on the platform, you'd aim to do it at 9:06. After that, the trains will meet in multiples of 6. So the next time they meet will be at 9:12 and 9:18 and so on. So let's look at how we would find the LCM of a few different numbers. For 3 and 5, you could list the multiples of 3, so 3, 6, 9, 12, 15. And the multiples of 5, 5, 10, 15. And you'll see that 15 appears in both of them first. So we say the LCM of 3 and 5 is 15. You can do the same for 5 and 8. I won't list out the multiples, but I'll tell you that the lowest common multiple of both is 40. For 7 and 8, it's 56. For 2, 3, and 5, well, we already worked it out for 3 and 5. It was 15. So what's a multiple of 15 that's also a multiple of 2? It's 30. So the LCM of 2, 3, and 5 is 30. Well, you might be thinking now, the way that we work out the LCM is we just multiply the two numbers. 15 is 3 times 5, 40 is 5 times 8, 7 times 8 is 56, 2 times 3 times 5 is 30. So what about the LCM of 6 and 4? Well, you might think that it's 6 times 4, which is 24. But we just saw in our earlier example, when we were adding those two fractions, that the lowest common multiple is not 24, it should be 12. So why is it that we can find the LCM of some numbers by multiplying them together, even three numbers, but others we can't? The LCM of 6 and 4 is smaller than 24, and the reason for this is they share factors in common. So to learn more about this and how you can work out the LCM all the time, please join us in our next lesson. Thank you and goodbye.